Hi, I'm Angel Oakley, and I am here in River Forest at the Greenbuilt Home Tour. And this is the first passive house in northern Illinois. We're going to go inside and take a look and talk to the architect and builder and find out a little bit more about this house. Okay, so we are in the passive house in River Forest, and we're looking at the siding,
Right.
which is...
It's LP Smart Side composite. It's engineered wood product, so it's comes in long panels. It's really impact resistant, and it gives you that cedar look without the maintenance of cedar. So it comes with a 25-year finish warranty, double coat, factory finish.
Okay.
And then you get a 50-year warranty on the product itself. So the whole house has a home automation system attached to it too. Our heating and cooling for this house is all done through two of these units here. They're 9,000 BTU mini splits, ductless. So basically we're just conditioning this room. And then ERV is helping like a kind of a Vitamix or blender for your house and mixing that all up. So we get stable temperatures throughout the whole house. Today we got a lot of people and bodies coming in and out, so not optimal as it would be on normal conditions. But the floor in this room is just strand bamboo, not carbonized. So strand is 154% harder than oak. No added urethane formaldehyde, non-toxic finishes, 10 coats of finish, so it's super resilient to scratches too. So it's not only impact resistant, but very scratch resistant as well. They have dogs, cats, kids. Yeah, they have dogs, cats, and kids, and you can't tell. Then we have, let's go to the windows here real quick. These windows are all European-made windows. They don't make American windows quite to the efficiency. There is one passive house window company in America, or a company that just got certified as a product, but the glazing companies in the United States, there's only two glass companies, so that's the problem, is that you get a super efficient window, heat loss wise. You also get a window that doesn't allow any sunlight in. We live in a heating dominated climate, so we want that sunlight to come in. We want to shade that sunlight due to recessed windows or shading devices on the outside, but allow that solar heat gain to flood this house in the winter, because that's our main furnace right there, not this thing. It's this and the bodies in the house that are going to do that. So these windows are 0.5. They allow half of the visible light to come in the wintertime to help heat the home, while also being 0.12 U factor, so super efficient. About an R8 window, so more efficient than maybe one or two of your walls at home. Another cool thing is all this German hardware you can do some cool things with. So it's tilt turn, so you can open the window like this, and that allows you to open windows when you're not home, and no one can break in. Just push a screen in. I mean, you got to still get through this window with the hardware to get in this house. There are screens for these windows. That's another question I've heard today. And then it also can open, kind of like a casement, but opens into the home for easier cleaning here. So look at the thickness of that window. It's got double gaskets on it, triple locking point, so when it seals, when it's shut it, these gaskets seal, and then you lock it, and it really just sucks that window tight together. And it's thermally broken, so you can't get American windows to this level of thermally broken or decrease in thermal bridging. So this strip right here you see is actually kind of the European equivalent of a foam board. It breaks the conductive heat loss through your window frame. And the windows, actually most efficient part of the window is the glass, and not the frame in this case for these windows. So that's why the bigger the windows, you get a better ratio of glazing to frame, and that overall increases the energy efficiency of your home.
What's the name of the company again?
Zola.
Zola?
Yeah. Let's head into the kitchen here. So the kitchen, we have a cork floor, so again, a very eco-friendly, rapidly renewable zero-space with a bar kind of tree, and it regrows and they can harvest it from the same tree over and over again. We have the Cambria quartz countertops again. The cooktop is electric induction, so it's not your typical electric, it's induction, so it actually has an electromagnetic field that's going to heat the pan, which is going to heat the food. It's not like a gas where you're just blasting it, and a lot of that heat's escaping through the sides and everywhere else. We're only heating the elements, so if the pan's on here and you have your hand on the cooktop right here, you're not going to feel or burn yourself. Also, you can boil water on there in less than a minute and then pull it up and put your hand right on it, and you're not going to burn yourself. So super safe. You can't even turn it on without having the electromagnetic field of the pan starting the connection.
Does it tend to respond fairly quickly?
Yeah, so if I'm boiling water, I could, and I just want to simmer it, I can press this button and you actually see the bubbles decrease all the way down. You could put chocolate in a pan on this, put it on setting 1, walk away for 2 hours, and you're never going to burn that chocolate. So much control. A lot of chefs are actually, gourmet chefs are switching to these because they have so much control on them. And it's the same every time versus like a gas, you're kind of like, okay, I'm medium, high. You're never going to get that same number. This is digital display that pops up that actually gives you a number, so you can set it exactly to that same.
Are there several manufacturers who do these?
Yeah, this is GE. Wolf has them. Yeah, they're all over the place. So that's great.
You have to use pans made of ferrous metal in order for it to work.
Right.
Oh, say that again?
So yeah,
Steel.
Hands that are iron or steel
And
or
iron steel.
ferrous metal.
you need a magnetic field to help keep this element. Cabinet stains the basement. Some of you missed that. So no added urea formaldehyde, non-toxic water-based finishes. We have slow close hardware and cabinet doors. We actually make effective all the space in the home too. So we have storage in our toe kicks here. We allow for additional instead of just wasted space. So and it's just the pressure we kick it and it opens up. So pretty cool. Some people put their pets' bowls and stuff in there too. So you know.
That's a great idea.
We have the glass backsplash here. I'll look over the grouting things later. And then the main control for the ERV is right here in the kitchen. So you can do boosts here. There's also boost switches that are in all the bathrooms. So if you're taking a shower, you can boost that, which will get rid of more air out of the house, but get rid of that humidity in your bathroom as you're taking a shower. Because this is a passive house, we don't want holes all over the walls, right? So, and because we don't have this house is, so efficient that we don't need natural gas. Natural gas is cheaper than electric, but our load and electrical demand in this house is so low that we only have electric. It doesn't make sense for us to pay the $15 a month Nycor hookup, and then plus whatever we use. So we don't even have gas here. So we're using that. And because we don't have gas, we can use a recirculating hood. Basically has grease traps and filters here, charcoal filters at the top, and then we have our two exhausts for the ERV on both sides of the kitchen here too. So you could cook bacon in here, and depending on your personality, it may or may not be a bad thing, but an hour and a half later, that smells completely gone. The homeowner for this house wishes it stayed around a little bit. That between the concrete and the insulation, we have a vapor barrier that's all taped in airtight, taped to the walls. And that way we don't get any kind of soil gases, but also we don't get air infiltration, which is super important in passive houses. Passive houses homes are super insulated and super airtight, super healthy and super comfortable basically, and durable. Because I'll go ahead and the insulation of the walls is R54, the attic is R100. And our air changes per hour is 0.39. The new Energy Star just came out is 3.0, so we're 100 times better than that, or 90% better than that. So because of that, we really want to, it does a couple things for the house. One, you have low utility bills, but also the building science side of how we flash the windows, the redundancy of our flashing, make sure we don't have bulk water issues. Our siding is actually 3/4 of an inch off the wall to allow bulk water to drain via gravity. Residual moisture, there's vents at the top and bottom behind it too, so insects can't get there, but airflow can get back there and dry that out. It also doesn't have any pressure to drive things through nails and screws to dry moisture in the house. Because the house is airtight, we don't have that moist air on a day like today trying to drive its way in and condense on the backside of the drywall. Our walls are thermally broken, so we don't have conductive condensation due to two temperatures hitting. And because we have 1/3 of our R value on the outside of our air barrier, we don't have any risk of interstitial condensation, which is by two temperature air is hitting. So we've eliminated all risk of moisture, which moisture leads to 95% of building failure. So this house is not only super energy efficient, super healthy, but it's going to last for hundreds of years without any major remodeling or work. It's just built to a scientific approach versus a traditional approach to construction. And
What's the purpose of the bricks?
the bricks, that's actually part of the house that we took off, so it's part of the old house basically. Instead of sending them to a landfill, in this case these are old Chicago condos, so you wouldn't send them to a landfill anyway, people take those and pay for them.
Yeah.
But, we wanted to keep some of that historical context of the site intact. We used some of the old lumber from the old house to use for our bracing for construction. We donated a lot of the old windows, we used 2 of them on the garage that's detached and unconditioned. Those old, we finished it we took it to an auto shop and had them sprayed with a nice long lasting paint, things like that. The drywall in this house is all Certainty Air Renew. So it's, not only is it formaldehyde free, but actually absorbs formaldehyde, aldehydes, and VOCs, breaks them down and stores them as non-volatile. So it's actively cleaning the air. So we know when we bring into a home, we look at third-party certifications for all the materials we bring into our home to make sure it's healthy. But also, we don't know what clients are going to bring in for furniture, so we kind of put that in as a buffer. So if they bring in some of the furniture that might have some kind of toxic elements to it, it's going to help eat that, basically. And we actually, not only are we claiming that we're using healthy materials, but we test that on the back end of our construction. So we do analysis on SVOCs, TVOCs, particulate counts, and also formaldehyde and all aldehydes in our houses, and give that info to our clients. So very transparent. We know we're doing a great job. We're specifying everything the right way. So why not just give everyone, transparency on that? And like I said, just because it's UVOC doesn't mean it's non-toxic. So sourcing materials is super important. I purchase all the materials, finishes, glues, even for the carpenters and people. I buy their caulks. If they want to bring something to the site, they have to pass it through me, because it has to meet our criteria. And I have to research it. The countertops in here are the same as the kitchen quartz, Cambria, and the cabinets. It's the same throughout the house as well. There are no added debris, formaldehyde, non-toxic water-based finishes and stains on them.
Well, passive design has been going on since the 70s in the US, and it really took off for a while, died again when the energy crisis stopped in the 70s, late 70s, early 80s, but it really incubated in Europe and came back as a standard, the Passive House Building Energy Standard. So it's a super low energy way of building. It's the most stringent building energy standard in the world. And we were able to achieve that by designing a very well insulated, compact house with windows in strategic places so they get heat for us in the winter when we need it. Where you can really see what I call the furnace of the house, which is that big window in that family room area. So the only mechanical activity we have going on here is the ventilation system, which runs continuously. So you get clean, filtered, fresh air. Every 3 hours or so you get a whole new house full of fresh air. And then there's a little bit of point source heating and cooling and dehumidification with these little Mitsubishi units. So it's amazing thing about Passive House is that it uses about 1/10 of the heating and cooling energy of a conventional built-to-code house. So it means a very comfortable, healthy interior. The other big thing we focused on, in addition to the passive design, is healthy interior. And that's where Brandon Weiss, the builder, really brought a lot of his expertise to bear. All the specifications were selected for non-toxicity and for no VOCs, etc., no aldehydes, formaldehydes. So it's a healthy, comfortable home.